AT1031. Chapter 1B. Engine Construction. Operating Principles of Gasoline Engine. How does gasoline engine turns fuel into power? A mixture of air and gasoline enters the cylinder. The upward movement of the piston compresses the air and fuel mixture. Then, the compressed mixture reaches a very high temperature and pressure. The spark plug ignites the compressed mixture, resulting to explosion of highly pressurized burning gas inside the cylinder. Then, the reciprocating motion of the piston is converted into a rotary motion of the crankshaft through the connecting rod. What is top dead center (TDC) and bottom dead center (BDC)? Top dead center, or TDC, is the highest position reached by the piston inside the cylinder. BDC, or bottom dead center, is the lowest position reached by the piston inside the cylinder. What is total piston displacement? Total piston displacement directly affects the power output of engine. The bore and stroke determines the displacement of the cylinder. To obtain total piston displacement, multiplying the piston displacement of a cylinder to the number of cylinders. What is compression ratio? Compression ratio is the comparison between the following: volume of the cylinder when the piston is at BDC, volume of the cylinder when the piston is at TDC. Generally, the compression ratio of gasoline engine is between 8 to 11, while for diesel engine, it is 16 to 24. Firing order and running mate. Firing order is the sequence of combustion of each cylinder in a multi-cylinder reciprocating engine. Firing order is the sequence of the sparking of spark plug in correct order for gasoline engine or injection of fuel for diesel engine. Running mate refers to the movement of pistons of the same direction, regardless of event inside the cylinder. As shown, the running mate of piston 1 is piston 4, while the running mate of piston 2 is piston 3. 4-stroke cycle engine. Engine cycle is a repetition of intake, compression, combustion, and exhaust strokes. Crankshaft makes 2 revolutions to complete one engine cycle. Intake stroke. On this stroke, the air-fuel mixture is drawn into the cylinder when the intake valve is open, while the exhaust valve is closed. As the piston moves downward, a partial vacuum is created in the cylinder. Then, atmospheric pressure forces the air-fuel mixture into the cylinder. Compression stroke. On this stroke, the air-fuel mixture is compressed, while both the intake and exhaust valves are closed. As the piston moves up from BDC to TDC, the air-fuel mixture is compressed, increasing the pressure and temperature for easy combustion. Combustion or power stroke. During combustion stroke, while both intake and exhaust valves are closed, the engine generates motive power for the vehicle as the piston moves downward. Just before the piston reaches TDC end of compression, the spark plug ignites the compressed air-fuel mixture. The explosive burning of mixture creates high-pressure gas, which forces the piston to move downward. This force becomes the engine power. Exhaust stroke. On this stroke, the piston moves upward while the exhaust valve is open and the intake valve is closed. As the piston moves from BDC to TDC, the burnt gases moves out of the cylinder through the exhaust valve. When the piston reaches TDC, intake stroke starts again, repeating the engine cycle. Two-stroke cycle engine. The two-stroke internal combustion engine is different from four-stroke engine, because it completes the engine cycle in only 2 strokes, and 1 revolution of crankshaft. This allows a par stroke for every revolution of crankshaft. Intake and compression stroke. 3 things occur as the piston travels upward. A. It closes both the intake and exhaust ports. B. The air-fuel mixture is being compressed. C. The air-fuel mixture enters the airtight crankcase due to vacuum. When the piston reaches the TDC, the air-fuel mixture is compressed, and the crankcase is filled with air-fuel mixture. Combustion and exhaust stroke. Combustion starts when the spark plug ignites the compressed air-fuel mixture. As the piston moves downward, 2 things occur. 1. The exhaust port opens, and the burned gas escapes the cylinder. 2. The downward movement of piston pressurizes the mixture in the crankcase, and when the intake port opens, the air-fuel mixture enters the cylinder. This brings us to the end of this topic.